Hello, good evening, Josh.
Good evening po.
Good evening, no?
Engineer.
Okay, so we will continue with our discussion on time rates. But before we start solving on volumes regarding cubes and spheres, first we need to review the last topic we discussed, which were pertaining to the time rates of certain triangular problems. So here, as is stated in the problem here in the board, would you kindly solve this problem, Josh, as a review of our topic last meeting regarding triangular problems in time rates?
These are pre-made figure. Okay. So let this be h, x, y.
Hello.
Okay, so you're solving for the other side or one side of a triangle which is unknown. Okay, 2h.
Then this is equal to 0 because h is not changing. It's constant sa ladder. So then the entire term cancels. Transpose. Substitute.
Y 12 ang yun. Unit yung 12.
When computing, you should you could put the units, but it's better to omit the units in the middle of the calculation.
Okay, so our answer is for the rate of change of dx is equal to 7.2 feet per minute. Now, I would just like to add in the solution, our dy dt from positive 3 feet per second becomes negative 3 feet per second since we're considering it's a vector. So going down, okay, the one part of the ladder is going down. So positive 3 feet per second now becomes negative 3 per second. That's why our solution is negative 2 multiplied by 12 and multiplied by negative 3. So positive 3 feet per second becomes negative. We're converting it to a vector quantity, meaning it's going down, going to the negative y-axis, so it becomes negative. So our answer now is 7.2 feet per minute. So that's the rate of change of the x part of the triangle. Okay, Josh, that's correct. But I think we're not through with that problem yet. Okay, there's another one. It's asking how fast is the area increasing. So area of a triangle is equal to 1/2 base times height, or in this case, area is equal to 1/2 of x and y. (72), 7.2. Feet squared per, is it in minutes, Josh? Okay, I think that's correct. So explaining it further, we use the formula for multiplication in the differential calculus. So first term multiplied by the derivative of the second term, and then the second term multiplied by the derivative of the first term. That's how we got 1/2 x dy dt plus 1/2 y dx dt. And then inputting the values of x dx dt and y and dy dt, which we solved earlier. So we got the value of 35.7 feet squared per minute. Okay, so I think you understood our last topic, last session, Josh. So very good. So now we're going to start solving for volumes. I think I'll be the one to solve this first one. It states that, wait, it's gone. Where's the problem, Josh? Okay. Okay, there it is. Okay. It states that a spherical balloon is inflated with gas at the rate of 900 cubic centimeters per minute. How fast is the radius of the balloon changing when the radius is 12 centimeters? Okay, now assuming that the balloon is a perfect sphere, okay, which is actually, I think there are perfect spheres balloon, but not that perfect. Okay, so but I'll draw it as a perfect. Hopefully it's clear. There's perfect circle. So let's go here and a reflection. Okay, so let's say we are putting air inside the balloon. Okay, so here meron daw siya. I mean, the volume is expanding at the rate of 900 cubic centimeters per minute. Okay, so I think I'll do that first. So dV dt is 900 cubic per wait, minute. Okay, so we're also given the radius. Okay, so assuming that it's here, assuming this is the center. Okay, so we're given the radius of 12 centimeters. So we're injecting, or we're putting air, it's inflating at the rate of 900 cubic centimeters per minute. Okay, now the question is, how fast the radius of the balloon changing? Okay, so we're going to use the formula for the volume of a sphere, since it's a spherical balloon. So our volume now is equal to 3/4, sorry, 4/3, sorry, 4/3, 4/3 by r cubed. Okay, now let us differentiate this. We have dV dt is equal to 4/3 multiplied by pi, and then the derivative of r cubed is 3r squared, and then your change in radius, which is dr dt. Okay, now we know that dV dt is equal to 900 cubic centimeters per minute. Okay, so I'll just be putting the values, or first I'll be isolating dr dt. So this is equal to 900. So this 900 all over. Wait, we could cancel 3. Okay, so we are left with 4 pi. And then r squared is 12 squared. Okay. So I repeat, I isolated dr dt. So dr dt now is equal to your dv dt, which is equal to 900 cubic centimeters per minute divided by 4 pi and your r squared, which is equal to 12. Okay, so what's the value of dr dt? Okay, Josh, could you help me to solve this also so that we could concur if we have the same answer in solving? Okay, so 900 divided by,
0.497 po.
okay, we're correct. What's your answer, Josh? 497. 0497.
Aba.
Okay, so we have the same answer. 0.497. This is in centimeter per minute. Okay. Could you still see it,
Yes,
Josh?
hindi. Opo.
Okay. So is the solution clear, Josh? We
Opo.
just dimension the volume. Okay. So now it's your turn. The next problem is actually it's like the same given. Okay. So kindly read the next problem.
Sure.
But wait, Josh. Before you start with that, I'll just have a point here. So DVD here, although volume is not a vector quantity, it is a scalar quantity, but we still have to assign a sign for the volume so that we know if the volume is increasing or decreasing. So if we have a volume or derivative of the volume is positive, meaning your circle or your cube or any solid is increasing. Now, if it's decreasing, we're going to use a negative value to signify that it is decreasing. But it doesn't exactly mean that you have to. But it's better to signify a sign if it is decreasing, because we know area and volume are not scalar quantities. They are they are not vector quantities, they are scalar quantities. So you need to do that. But mas maganda kung lalagyan mo rin para ma-signify na lumiliit siya o lumalaki siya. Now, in this case, since wala akong signs positive, kasi it's inflating. Okay? Is it clear, Josh? It's not really necessarily na kailangan gawin, but it's better to signify. Alam natin kung lumalaki siya or lumalaki siya. Lumilit siya, parang ganun. Okay. So, could you solve the next problem, Josh? Okay, so I'll read the problem. The surface area of a snowball decreases. Okay, as I explained before. Okay, at a rate of 6 square feet per hour. Okay, mga kapakabagal. Okay, how fast the diameter changing when the radius is 2 feet? Okay, sige Josh. I think it's quite the same. And
Na.
high-tech illustration again. Okay. May I ask, Josh, regarding the illustration, did you do this shading the figure or did you get 3 circles?
Ginawa ko po, yung ginawa ko po, Talagang 3 circles po na pinag-ganon ko po. White, nilagay ko po whiter
Lighter.
circle. Para
Ah,
mag-contour po siya.
kasi perfect yung ano niya, kung shading siya, perfect yung pagka-shade. Kaya I just ask you if you what you did. So 3 circles, bali on top of one. Okay, so I think the problem is quite simple. It's easy to understand, and then the value is negative, although it is feet per hour. You forgot the R, HR, feet per hour. The final answer, Josh.
HR.
HR. You forgot the R. The R. Okay, so that is correct. So it is decreasing at 0.238 feet per hour. Okay, the radius is decreasing at that point. Okay, so next problem, Josh, is it still a circle? Okay, no, it's now a cube. Okay, so let's see. The problem states that the side lengths of a cube are increasing at the rate of 5 centimeters per second. How fast is the surface area of the volume increasing when the side length is 10 centimeters?
Mhm.
Okay, 6s squared. Well, that's this. So 50 times 12. So 25 times 5. Okay, so it's correct. I think this problem is quite simple, Josh, especially for you. Since we're just substituting, we're going to differentiate the formula and substitute the values. Maybe next meeting we'll do the same problem, but siguro with different, let's say it's not a cube. Let's say it's a rectangular box where the length is increasing at a certain rate while the width is increasing at a different rate. So that the problem will be not harder, but more difficult than this one. Okay, so that's correct. Next problem. Okay. Gravel is being dumped from a conveyor belt at the rate of 100 cubic feet per minute. Okay, forming a conical pile whose base diameter is 2 times the altitude, 2 times the height. Okay, how fast is the height changing when the pile is 12 feet high? This reminds me of a problem in maxima minima, Josh.
Aba. Tanananan. Actually, hindi ko po nalagay, pero yung ano po, yung diameter is this, whose base diameter is 2 times the altitude. So, we can imply that since d equals to h,
22H.
r equals h. Yeah, very, very realistic po na, ano, very realistic illustration.
Oo nga.
So, how far is the height, how fast the height changing? So, since r equals to h,
solution is complete. Josh, show the solution of the 1/3 being cancelled.
I forgot pwede pala ano. Pwede pala
Okay. It's 0.221. Okay. Okay, that's correct, Josh. Okay, so maybe next meeting we'll continue with the volume problems, but maybe a little bit harder or a little bit complicated than these ones. Okay, at least you know the principle. Okay, in using the formulas and deriving them. Okay, so I think that's all for today, Josh. We'll meet again next meeting. I'll be looking for problems or creating problems with the same format of solution. Okay, so thank you very much, Josh, and I'll see you again next meeting.
po.
Thank you,
Thank you
engineer.
po.
Have a nice evening.
Yes
Sige
po.
po.
Thank you din po.